Hello everyone. It's come to my attention that the previous video, 2.5 Limits at Infinity, and I think it's part 1, didn't have any audio. And what I'm going to have to do is just invest in a new mic. This mic I have is very old, and sometimes the wire or whatever, I don't know. Anyways, I'm going to record the video again. So what I'm going to do is start by defining limits at infinity and horizontal asymptotes. So what we're saying here is this. If f of x becomes arbitrarily close to a finite number L for all sufficiently large and positive x, then we write the limit as x goes to infinity of f of x equals L. The idea behind this, and I think your book does a really good job at just showing a picture. So what I did is I just copy and pasted this from our book, is that as you can see here, and I'm going to highlight so you know exactly where I'm talking about. So I'm looking at the bottom left-hand corner of the screen. So as x goes to infinity, notice that our function starts to increase, but it is bounded by L, which is that horizontal asymptote. Now, what we can do is we can actually use limits, and that'll help us find where these horizontal asymptotes actually are. The same applies to the other side, which is if we allow the limit as x goes to negative infinity of f of x, and that's going to approach a different value, m. So once again, like I said, your book does a really good job at showing this. So I'm gonna do it in green. So here's x goes to negative infinity, and you can see here our limit is approaching this horizontal asymptote there. Now, just so we know this, and just to go over this real fast, from algebra class we learned that horizontal lines have the equation y equals some number. In this case, I'm just going to call it, y equals a. So we can use limits at infinity to help us find where do these horizontal asymptotes actually lie. Now, before we do that, let's just understand how do we actually evaluate limits at infinity. So part A here is actually pretty easy, okay? And if I just read this here, it says the limit as x goes to infinity of x to the 12th. So I think an easy way to kind of think about this here is, well, what if we just start choosing arbitrary values for x? And let's see what happens. So if I let x equal 1, then I know this is going to be 1 to the 12th, which is still equal to 1. If I let x equal, let's say, 2, this is going to be 2 to the 12th, which is a very large number. I don't know what the number is. If you give me a second here, I got my calculator to my left. It's 4096. But once again, it's a very large number. If we let x equal, let's say 5, that means we're going to have 5 to the 12th. And 5 to the 12th is, I'm going to have to write it underneath, 244140625. It's an enormous number, okay? Let's see, 1, 2. Looks like it's, I can't even read. I didn't write clear enough. 244,140,625. I don't care what the number is. What I do know is this. It's a very, very large number. So what ends up happening with this first example is that as x goes to infinity, we know the values of x are just going to get larger. And if you keep taking large numbers and you raise them to the 12th power, you're going to get further large numbers. So the answer to this limit is just infinity. It's going to go to infinity. Now, if we apply the same logic to the next problem, notice what we have here. The first thing I'm going to do is I'm going to rewrite this as the limit as x goes to negative infinity of 1 over x to the 11th. Because I applied my negative exponent rule. So if I go ahead and if I start picking values here for x, starting with -1, and then -2, and then -3, and so forth, we should start to see something happening. So what I'm going to do is I'm going to open up Microsoft Excel, because that's going to make my life so much easier in terms of computation. I highly suggest you learn how to use Microsoft Excel. If you have access to anything else like SPSS, which is a statistical software package, or if you have access to, what's the other one? R, that's free. You could download R if you have access to Mathematica, MATLAB, all that stuff. If you're interested in learning about that, just shoot me an email, all right? And I will help you to get all that set up. There are free versions of this stuff, but there are also paid versions. It all depends on where you go to school. If you're a CCAC student, I know we don't have that on campus, but I do know if you go to a four-year university, they usually have deals with Mathematica or OpenWorks for MATLAB and stuff like that. So, like I said, you want to know how to do that, just let me know, and I can help you out. So here's what I'm going to do. The first column, I'm going to label it X. The second column, I'm going to label it X. Actually, let's do 1 over X to the 11th, okay? And what I'm going to do here is I'm just going to type in a formula. I'm going to say the first cell is going to equal -1. And the second cell is going to equal the previous cell -1. So that gives me -2. And I'm just going to scroll this down so we start getting negative values. Because remember, we're letting X go to -infinity. And in this cell, I'm just going to hit equals 1 divided by the previous cell, all raised to the 11th power. All right, so the first one, and we get what we would expect, -1. But as I scroll down, look what happens to all my values. I'm going to move this all the way over here, and we'll zoom in here a little bit so we get a better look at these numbers. So for the first value, we got -1. For the second value, we have -0.000488281. Now, this is nothing more than, that E is 5.6 times 10 to the -6th. This is going to be -2.3 times 10 to the -7th, -2 times 10 to the -8th, and so forth. So my values are getting smaller and smaller and smaller. So if we go back to this, and like I said, if we think about this, this is going to go to 0. Because my values of X are getting closer and closer and closer to 0. Another way that we can view this is just by using Desmos. We could just type it in. So let my computer do this real quick. There we go. There's Desmos. Graphing calculator. 1 divided by X to the 11th. Now, you got to remember, we are going to -infinity here. So all I'm going to do is just kind of close this, and here are my negative values. And notice how they creep along that horizontal axis there, which is y equals 0. So our limit as X goes to -infinity of X to the -11th is equal to 0. The key is to rewrite it so that it's 1 over X to the 11th. Now, if we take that and we extend it to the next two problems, you can kind of see how this is going to work. So real quick, I'm going to just change my marker. Limit as X goes to infinity of the quantity 5 plus 1 over X plus 10 over X squared. Well, if you think about this, we can apply those limit properties that we learned about. So this is going to be the limit as X goes to infinity of 5 plus the limit as X goes to infinity of 1 over X plus the limit as X goes to infinity of 10 over X squared. We know the limit of 1 over X, well, that's going to go to 0. And this is going to go to 0 because that's going to be 10 divided by an extremely large number, which is essentially 0. This, you don't have an X value, so you have nothing to substitute the limit in for, so it's going to equal 5. So the limit as X approaches 0, or as X approaches infinity of the quantity 5 plus 1 over X plus 10 over X squared is equal to 5. For the last example, what we're going to do now, initially, hopefully, you're not thinking this goes to 0. I hope you're not thinking that because that is absolutely incorrect. And the reason why it's incorrect is if you look, we actually have a monomial in our denominator, which means we can simplify this a little bit. So what I'm going to do is I'm going to separate every single term and divide it by X to the second. And by doing that, I get the limit as x goes to infinity. Sorry, I forgot to put this in parentheses. So I get the limit as x goes to infinity of 4 plus 2 over x plus 3 over x squared. And just like the previous problem, 2 over x is going to go to 0. 3 over x squared, that definitely goes to 0. So you're left over with nothing but a 4. So the limit as x goes to infinity of 4x squared plus 2x plus 3 all over x squared is equal to 4. So just because you see like something in the denominator, do not automatically assume that, oh, it's going to go to 0. You're going to have to do some sort of algebraic simplification first. I hope this helps. And there goes my dog barking. So I hope you enjoy his bark. I will see you in the next video. Bye.